Hello, and welcome to a video about electronic voting on blockchain. My name is Brian. This project is the sum of two of my open source projects. These, plus my other works, are published openly on the web and are licensed free for use by anyone or any organization, including commercial and public service. I would like to begin with the motivation. What benefits does electronic voting provide us? First, new technology gives us an opportunity to have free, open, honest, and transparent elections. Anyone with access to the internet can see all the votes in an election. Second, the votes are stored on an immutable public blockchain. The votes will be stored there forever and will be verified cryptographically over and over again. Nobody can ever lie about the voting data. Third, anyone who can legally enroll can vote anonymously. All the system knows about the voter is a unique number that the voter creates and controls. Fourth, any voter, once enrolled, can vote with any internet-connected computer and at any time while the election is running. All that is needed is a smartphone, and it doesn't even need data or cell service. Last, and most importantly, is we can save the taxpayer a great deal of money. We can deploy an election on blockchain for pennies or a couple of dollars, and each vote costs only pennies to record. With elections this cheap, we can expand the democratic process and close the gaps between public policy and common sense. Today we have two major parts to the video. In the first part, I'm going to present a series of slides to illustrate the overall concept of how this works. And in the second part, I'm going to do a software demonstration from the development environment on my desktop. Now I'd like to explain a little about how the system is designed. It's made up of three kinds of smart contracts. A smart contract is a small chunk of code that exists on the public blockchain and can be inspected by anybody. The blockchain and all resident smart contracts exist as copies in a global network of cooperating computers known as Ethereum, a peer-to-peer network. Ethereum has a naming service that's similar to the web's domain service DNS. This version is ENS for Ethereum Name Service. As an example of how it would be applied here, I have picked a jurisdiction called Cascadia. So in ENS that is cascadia.eth. We have a registrar's smart contract and a voters list smart contract. And then we might have at least one, hopefully many specific elections that might be named as shown, with the year and specific string to indicate that, say it's the 2022 general election .cascadia.eth, something like that. The registrar's smart contract is simply a table, and this indicates Ethereum addresses for a group of people who are allowed to enroll other people into the voting system. We have a flag on each registrar to indicate whether they are enabled. We might disable registrars in exceptional circumstances, such as moral turpitude. Then we have a voters list, and the voters list is simply another table of public keys, a public key for each person who's allowed to vote. And the software enables the registrar to enroll voters and put their public key on this list. And then we have a third smart contract, the election itself. Inside we know we have a list of candidates, and each candidate is known by a cryptographic challenge, and the vote is the user's cryptographic response to that challenge, and I'll show how that works later in the video. Here are the major stakeholders in the system. At the top left we have the new position of Digital Chief Electoral Officer, who is responsible for making sure that the system integrity is maintained, and they would be responsible to the public. There would be one such person in every area, and their job would be to add registrars. They would also have to set up the smart contracts for each election and add and suspend candidates as necessary. Then at lower left we have a number of digital registrars. There would be any number per jurisdiction, perhaps one for every 10,000 voters, who knows. But they would have the responsibility to implement the voting requirements, so checking to make sure that someone is a citizen or otherwise eligible to vote. And they would be charging a fee for enrolling because it would cost them a few cents to enroll a voter, so they would pass along that few cents cost to the voter to complete the enrollment process. At top right we have political candidates. We might have any number of those per election. Every digital candidate is known in the system. Their identity is a public key, and to be a candidate in an election they have to sign a cryptographic challenge, and their response to that challenge is then published in a smart contract. And then at the bottom right we have the voter. The voter is anonymous. They're enrolled by their public key. We don't know a name or an address. We don't need to know anything about them. Just that when they were enrolled, they were allowed to vote. And our voters can vote by smartphone from anywhere at any time. Vote from home. Vote from anywhere you can get an internet connection. And the voter votes by digitally signing a chosen candidate's challenge, and that is placed on the blockchain. And the cost to do that, again, is merely pennies. And this is the end of the presentation part of the video, the end of the talk. Next up, we'll be going through demonstrating the software in the desktop development environment. But before we move along, I'd just like to acknowledge excellent comic strip xkcd.org, and this particular instance of the comic is referring to exactly what this is all about. So I hope everyone gets a chance to read that and enjoy it. And we'll return very soon with the software part. Thank you. And welcome to part 2, where we demonstrate the software. This is the good part. First, I'm going to run my own local Ethereum, just in memory. I've pre-configured with 2 test accounts. I'm going to need the private key for the first one in a second here. I'm going to set up some smart contracts by script and run the user interface. Now, the user interface comes with all the sources. It's all JavaScript and HTML, and it's run with this program called NW, which exists for all major operating systems. Here's what it looks like to start. You can select the skin at runtime, different CSS, and select the different language pack as appropriate. There are 4 functions across the top here. We'll start here. Now it's not connected to Ethereum in this case because it's on a different port. So I'm just going to change that. And now it is connected to Ethereum. It's come back with the default network gas price. Now I'm running this demonstration assuming I'm the registrar, duly appointed by my municipality or whatever, to enroll people. Now the app doesn't store user information. It's all just in memory, so it doesn't know who I am until I tell it by loading my Ethereum account. Now this Ethereum account has been configured by the Muni to represent me, the registrar, and I'm allowed to enroll people. And it's just how the test environment's been set up. So now how do I enroll somebody to vote? Well, I click here on the Enroll tab, and this is the name in Ethereum Name Service, ENS. This is the name of the voters list that we're using at the moment. Cascadia.eth I just set up locally. Now in order to enroll somebody, we need their public key. So how do we get that? We get that through a challenge response interaction. So it starts when the application issues a challenge. In this case, it's just a key and a signature represented by this QR code. Now I'm going to scan that QR code with my phone, but first I want to show the app that I'm using. It's this app in the Google Play Store. It's free. It says here the app is in development. It may be unstable, just like its author. So we'll put that down. Now here is the app again. I'm just going to sign this with my phone. And the app scanned this and generated a cryptographic response. Now, scan for the response. Takes a second for autofocus. There we go. So what happened there was we just did a cryptographic interaction. Digital signatures are exchanged, and now the voting app here on the computer knows that me, the user, this is my public key. It starts with a 03, and then there's these two values. And this is all one public key that represents me. Now when I enroll this voter, that public key has been added to a smart contract on the blockchain. We just saw the transaction go through 47,000 gas. And that's it. That's all there is to enrolling. Now, let's say we come back later and this same voter wants to vote. Well, he or she just goes straight into this tab and selects which election they want to vote in. And when they do, they're going to get the list of candidates from that election. Now in this case we've got 3 different options, so let's say we're going to vote for the middle option, Bob, like so. Now I'm just going to go back to my cell phone and use the same key that I used to enroll to vote. I can use that same key to sign this challenge, and this challenge is hard-coded into the smart contract when the election was set up by the digital registrar. And so in this case, my phone has generated a response to this, and I'm just going to scan it. And again, takes autofocus a second, but there we go. One thing I've learned is that using an HD camera is an absolute must for this. But now we have the voter's public key and the signature of the chosen candidate, and so now we can click on the vote button, and the digital signature itself has gone onto the blockchain in this transaction here, 34,000 gas, and there's the transaction hash. So that's all there is to voting. It's that easy. It can be done from anywhere and for pennies. Here there's just an About tab. So I'll put this down, and just to see where it is on the blockchain, in my test environment here I've got a script that I've set up. And I've run this command line interface command to fetch the event. So here's the vote as it's recorded on the blockchain. It's just the response, the cryptographic response generated by the phone. So the votes are counted by an off-chain process that can look at this string and parse out the public key of who voted and determine which of the candidates this person voted for. And again, all this is 100% free and open source and usable for any purpose. So that's it for the demonstration. Thank you very much for your attention. Have a good one.